Hi everyone, I welcome you all in the next lecture of ethanol production series. So in previous lecture, we have seen or we have already answered the question that how does a higher octane number enable more efficient engine? And that was one of the most important question of the whole series because we should know why, high octane number, enables more efficient engine. And we have seen that for both of these engines, we have seen whenever air fuel mixture has been injected into the uh, cylinder of the vehicle engine. So what happens? This piston basically moves upward and it compresses the fluid. It compresses the air fuel mixture, and due to this compression, what happens? The volume decreases, and because of increase in the pressure, and that eventually increase the temperature of the air fuel mixture. And in case of petrol, basically what happens if you go beyond a maximum compression ratio, like 8 is to 1 to 9 is to 1, then what happens? Since petrol molecules are, bonded by weak van der Waals forces of attraction, and it basically generates a free radical at higher compression ratio, and then it won't wait for the spark plug to generate the spark. Before the spark plug generates the spark, it basically the free radicals, due to heating of the free radical at higher temperature, it get pre-ignited, and due to the pre-ignition, and another spark that is being produced due to the a spark plug, and both of these spark collides with each other, and then that produces the vibration inside the petrol engine. But that was not in case of ethanol, because in ethanol also the air fuel mixes enters into the cylinder of the engine, and then it is getting compressed by the piston. But here you can have, flexibility of going for the higher compression ratio, because ethanol molecules are bonded by a hydrogen bond, which is stronger than the weak van der Waals forces of attraction. And we have also seen that the enthalpy of vaporization, or heat of vaporization for ethanol molecule is 2 times higher than the petrol. So it resists the knocking, it resists the generation of the free radical at higher compression ratio, and that's why you can have a higher octane number. And yeah, as we have also seen that in the previous lecture, that the compression ratio, if you increase the compression ratio, the engine efficiency increases using the mathematical formula. And this mathematical formula basically tells you that if you are increasing the compression ratio, the engine efficiency will increasing. And at a higher compression ratio, the increase in the thermal efficiency was not that much significant that it was earlier at the lower compression ratio. So we have already understood this concept in the previous lecture. So in today's lecture, we are going to understand another important concept. And it's also very important to understand that does the heat of vaporization of ethanol creates problem in the starting of the engine? Because as we have seen that heat of vaporization of ethanol is very high, right? So it was approximately 840 kilojoule per kg. And that was facilitating the higher octane number and higher anti-knocking resistance characteristics. But there are some disadvantages of having higher enthalpy of vaporization of ethanol. And let's see what is the disadvantage. So why this evaporation is important? So as we know that there is a liquid fuel, because ethanol or petrol that we are using in the engine, that is a liquid fuel. And this liquid fuel is getting evaporated inside the engine. And then what happens? This creates the fuel vapor. And once it creates the fuel vapor, basically your spark plug creates the spark, and then the combustion of this fuel vapor takes place inside the engine. And then due to this combustion, what happens? This pushes the piston outside, and then the crank rotate, and the movement of vehicle takes place. But what happens in the cold engine? So let's say if you operate the engine at a lower temperature, let's say 5 degrees centigrade or lower temperature. So that is what the temperature that we observe in the winter in the North India, especially. If I'm talking about in the perspective of India only. So in India, the in north side, you will see the temperature goes below 10, below 5. Right there, this kind of ethanol, if you are using ethanol as a fuel, that will create a problem. So let's try to understand how this will create the problem. So at lower temperature, what happens? The engine will be cold because the atmospheric temperature is cold, right? So when ethanol is getting injected through the fuel injector into the cylinder, then what happens? That, as I've told you, that ethanol absorbs the energy, right? And it absorbs a huge amount of energy because the heat of vaporization is 840 kilojoule per kg. So due to the absorption of energy there, the temperature of the engine will decrease eventually at that particular condition as well. So now you can see that outside temperature is itself is low, then engine temperature is also decreasing because of ethanol absorption. Then what happens? Ideally, if a spark plug is generating the spark, you want the fuel should get vaporized. But due to decrease in temperature, the fuel will take more amount of energy or more spark to get vaporized. So it will create less vapor due to the lower temperature, and that is the weak mixture in terms of burning of a fuel, and that creates a difficulty in ignition, and that's why it is very difficult to start that engine, right? So that's why at lower temperature you will observe that there is a difficulty in starting of the engine if you are using ethanol as a fuel. So that's why this will create a problem in winter season, especially in India, if the temperature is going below 5 degree or 10 degree. Now, coming to the solution for pure ethanol engine. So I'm not talking about blend. Just let's say if you have pure ethanol, you are using 100% ethanol, then what kind of engine we should design? Because engine is very, important when we are changing the fuels. As we have seen that the compression ratio, that is the maximum volume available for the compression by minimum volume, and that basically changes the efficiency of the engine. So that's why first, what happens since fuels are getting cooled in the engine because of absorption of the heat when we talk about the ethanol. So first, what happens? You should have a small petrol tank with the ethanol tank inside the vehicle. And then what happens? The intake air that is coming inside the fuel chamber, right, or cylinder, that should get preheated. Then it will require less amount of heat to, ignite the ethanol or ethanol air vapor mixer. And then you should have a heated fuel injector, because if, as we have seen, that temperature is reducing, and if you have heated fuel injector, then it will be, injecting the fuel at a higher temperature inside the cylinder, and then that will facilitate the easy spark or easy fire of the fire in the fuel inside the engine. And then we should have advanced electronic control where let's say it should the spark plug should wait till the fuels will get heated, and when it will get heated at that optimum temperature, the spark plug will ignite the fuel, right? So for in order to do that, you should have advanced electronic control system, and that is required. So I have just given you the four examples. This is something that we can incorporate in the or we can modify the engine if you are using the ethanol as a fuel, right? So this is all about the solution of pure ethanol engine. So I'll stop this lecture here. In the next lecture, I'll start doing some discussion about that is also very important. Why, if all of these problems are there, as we have seen that India is having cold weather also in winter. Out of all these problems, why is India promoting the ethanol blending, right? So we'll see India's, energy strategy in terms of economics, agriculture, and environmental strategy in the next lecture. Okay. So I'll stop this lecture. See you in the next lecture. Thank you all for attending the lecture. Stay tuned with this lecture.